Hi guys. All right, so here's our official first online new lesson. I hope everybody's excited. I will tell you though, this lesson definitely is it's tough. It's a tough lesson for us to be interacting together in the classroom, so it definitely will be a little bit tougher to be doing in this format. So you just do the best you can. Remember, you can pause, you can rewind, watch it again. Just go at your pace. And just keep in mind, I'm going to keep going, but you can pause and rewind. Okay, so a recursive definition. So the first thing I want you to look at is right here, recursive refer back. A recursive definition is just going to be another way to write a rule for a sequence. It's different than using those two explicit formulas. So first thing I want you to look at is this number line right here. If I gave you this number line and I asked you to fill in this position right here, I think we all know that would be a 4. But what would you do for this position if I gave you n? So this would be n minus 1, right? It would be 1 less than it. If I asked you to fill in this position on a number line, it would be a 6. And then 1 past the n would be n plus 1. So we're going to refer back to this. This is going to help us. All right, let's look at the definition. A recursive definition of a sequence is one in which each term after the first can be computed from the previous term using a formula. This is going to be the most important thing right here. A sub n is always going to be the next term. A sub n minus 1 is the term before it. So let's take a look at our first example. So it says, given the sequence 3, 5, 7, 9, 11, the recursive definition is. So it's a good idea here to say it in words. So the next term, that's what this means right here. The next term is the one before it and then plus 2, right? We can see this is a plus 2 pattern. We can also write it in function notation. And again, all you do is say the next term is the one before it plus 2. So I just need you to get it in your head that a sub n is the next term. A sub n minus 1 is the one before it. We're just going to say it in words. All right, so here we go. So we'll start our first one. Okay, so if this had said, write an explicit formula like we did on day 1, we would have used this formula. If it had asked for an explicit. But it doesn't ask for an explicit. It asks for a recursive. So first thing you have to decide, is it arithmetic or geometric? I kind of gave it away up here. It is arithmetic, right? We can see that this is a minus 3. All right, so let's just check and make sure that this is an arithmetic sequence. So we'll do second minus first. Is the common difference negative 3? How do we know? Go to your calculator. 18 minus 3, enter, minus 3, enter, minus 3, enter, minus 3, enter. Do you get that? And we do. Okay, when we write a recursive definition, you're always going to state what the first term is. And then you're going to say it in words. The next term is equal to the one before it minus 3. This is your recursive definition right here. That's it. You're done. So you always give me the first term, and then you say the next term is the one before it, and then whatever your common difference is. So that's how we would do a recursive formula for arithmetic. Let's try a recursive formula for geometric. So maybe on the side here, you guys want to put arithmetic. Now, I'm telling you it's geometric. We would have to test for it every time, but I want you to be super organized here. Okay, so again, here we go. Write a recursive formula. So one reason I know that this is geometric is because I can see the alternating signs. See how it's a positive 9, a negative 18, a positive 36. Remember in class for day 2 or in the video for day 2, I said that if we have alternating signs, it's going to be a geometric sequence. Okay, so first let's find our common ratio. So we're going to do second divided by first. Our common ratio we think is -2. Let's check in the calculator. 9 times -2, enter, times -2, enter, times -2, enter. Do we produce that sequence? Yes. Okay, we're writing a recursive definition. You always have to state what the first term is. And then we'll say the next term is equal to the one before it times -2. So that's one way we could write the answer. The other way you could write the answer, we'll say or here. You still state the first term, but you could say the next term is equal to -2 times a sub n minus 1. You could put the -2 in the front. Alrighty, so those are two great examples. Most important thing for each one, you have to give me the first term for a recursive formula. And then you start out each one with the next term is equal to the one before it, and then whatever it may be. If it's arithmetic, it's plus or minus. If it's geometric, you're going to be timesing by something. Okay, let's try a Regents question. Here we go. Now, I know some of you guys automatically would be raising your hand and telling me ones that we could eliminate, so let's discuss that for a second. You know who you are, definitely in period 7. So it says a recursive formula for this sequence is, all right, so look, if it's a recursive, do I have a pen here? If it's what is going on? I'm too far over, I think. Okay. Oh. Okay, I don't know why my pen won't change. It's still on highlighter.